covered in the last session in the morning, it was about the conceptual aspects of multidimensional property measurement. Yeah. What we will do in today's session, again, we will try to go a bit slow today, this session, and we will try to look at different types of multidimensional property measurement methodologies. Most likely, you all have used one or two different types of methodologies that have been quite popular. But multidimensional property measurement, the attempt to produce multidimensional measurements, have existed for a long time. Yeah. And at different point of time, people have proposed different methodologies. And when I see in different journals, when I look at different papers, I see a lot of confusion with terminologies. People use the word multidimensional, composite index. They all mean different things actually, and people just get jumbled up. They just use. So we decided, so the presentation that I wrote with my colleague Maria Santos, it was the main reason was to define the terminology. Yeah. So hopefully, I will be able to inform you about some of those issues this particular session. Then from tomorrow onwards, we will move to a particular methodological approach. Yeah. So in this session, I will try to go through these different methodologies. Some of you may have heard, may have used, but mainly we will try to talk about the advantages and disadvantages of these different approaches. So again, it's chapter 3 of the book and the same link for the chapter. Just wanted to show you something. So this is the website for the book. Yeah. And all the chapters, if you just go, if you just click the chapters, all the chapters are available for free read. Yeah. So it's not that you have to buy a book to read these things. All chapters are freely available and downloadable from here. Yeah. In terms of they are referred as working papers, but they're all available for you to access. Yeah. Okay. Terminology, typologies. So there are different ways people have tried to define multidimensional methodologies, multidimensional measurement. Yeah, we can broadly. It is possible that all measures will not fit in this categorization, but broadly, we can classify them into these 4 different categories. So you have 2 options: either aggregate them or leave them separate. So the decision is either aggregate yes or no. Second, whether they are based on macro data or micro data. And they all are different typologically. So we should not get confused. Even when we read, I read literature, I read papers, I always have to tell people that, look, clarify your terminologies. Don't just keep on calling whatever it is not. Yeah. So these macro-based methodologies, we refer to them as macro. If you aggregate them, they are macro aggregation approach. And the examples would be traditional composite indices, where you have macro level data. HDI is a macro index because you have all these aggregate at the macro level, you punch them up together. It's a macro aggregation approach. Yeah. Then you can have macro disjoint approach, where you look at proportion of women in parliament separately. You look at proportion of people without access to water. Dashboard. That means you look at MDG dashboard or SDG dashboard, different countries' performance, right, in different indicators. No need for aggregation. You look at them separately. They're different. Now, sometimes people give multidimensional approach. They're not exactly multidimensional approach. You can refer to them, but they should say they are macro disjoint approach. Actually, you are not joining them. Yeah? Then, within microdata, you can have the micro aggregation approach. The idea is to aggregate them to come up with one single index. Okay. And then you can also have micro non-aggregation approach. An example is Venn diagram. You can have Venn diagram, you can see the overlaps and all these things, what fraction of people have this joint deprivation into indicators and so on, but you do not do aggregation. So they fall within the umbrella of kind of multidimensional approaches, but this terminology should be clarified upfront. This is what I'm using. Because if you're using composite integration, we will see, based on the properties that we discussed, we will see what we generally miss if we aggregate or don't aggregate, use microdata or macro data and so on. Okay? Is the classification clear? Yeah.
What it means, like, aggregate indicators within yes and one.
So either you aggregate them or you don't aggregate them. So suppose you have literacy rate, mortality rate, per capita GDP and so on. You can either leave them as they are, or you can combine them to come up with one index, such as the HDI, then you are aggregating.
And microdata methodologies, what exactly?
So in Venn diagram, have you ever seen Venn diagram? In Venn diagram, do you combine the data to come up with an index? Is it possible?
No, because they have some.
So you do not aggregate them. But other index, you aggregate them to come up with a single index, right? They will fall in this category, micro aggregation. You get the micro data, you aggregate them to create an index.
For example,
NPI.
HDL.
NPI. Yeah. So any property index that you generate based on microdata, they would fall in that particular category. NPI is just one of thousands of examples. Any other questions? Make sense, the classification? Okay, so first let's look at some of the macro database methodologies and what we generally do. So in general, you denote the aggregate dimensional index corresponding to a particular dimension, D. It could be standard of living, it could be education, it could be health, and so on. And suppose that aggregate is denoted by HD. So per capita GDP, gross primary, gross enrollment rate, infant mortality rate, and so on. Yeah, the aggregate, macro aggregate for the dimension. And suppose we can just summarize these dimensional aggregates by a vector H1 up to HD. Yeah. Then macro disjoint approach, if you take, they will simply consider the vector of aggregate dimensional indices for evaluation exercises. So suppose you have these 5 different indicators for one country, 5 different indicators of another country. They will just compare indicator by indicator. That's all. No aggregation, no overall aggregation, that's all. Or just to see whether the country has improved over time or not. So over time, it has improved or did not improve. We look at indicator by indicator. In some countries, some indicators they improve, some indicators they do not. We just leave it like that. Like NDGs, SDGs, and so on. So there is no aggregation involved. Some people say, you know what, there are, and it's true, that sometimes certain things cannot be aggregated. It is better to leave them alone. Fine, but then in order to get an idea whether things have progressed or not, we just compare indicator by indicator. If you see there is an improvement in all indicators at the same time, you say there is improvement, like dominance. If you are mixed, you just say, I cannot say what has happened. Yeah. And then you have macro aggregation approach. What it does, it takes these vector or the set of aggregation, these aggregate, macro aggregates for evaluation exercises. So they aggregate them. Okay. So macro disjoint approach. Examples would be, so what you do, according to Alcar, Foster, and Santos, a set of dimension or indicators which applies a unidimensional measure to each dimension. Yeah, you look at each dimension, you aggregate them, you leave them there, no aggregation involved. So it is truly not a multidimensional approach. You look at multiple dimensions, but you do not look at their joint distribution, nothing. You just leave them as they are. and look at them separately. So basic needs approach, for example, you look at different indicators of basic needs. There was no possibility of aggregating them. Millennium Development Goal, Sustainable Development Goal. Yeah, the examples would be child malnourishment rate, infant mortality rate, illiteracy rate. So you leave them as it is, as if they're separate things. And in some cases, you have to understand aggregation is not possible. Microdata aggregation, percentage of women in poverty, yeah, percentage of children undernourished, and then even if you try to aggregate from microdata, you have some information on children, some information on women, and so on, and sometimes this joint population cannot be aggregated. Perfectly fine to leave them alone. It's not necessary to aggregate all the time. Okay. Now, what are the advantages? You can have information of as many dimensions as possible. You can draw information from different data sources. GDP can come from national accounts. Your mortality rate can come from administrative data or whatever. You do not need just one data set to look for. That's the benefit. You can just report those data. And of course, you can show information with this joint population. There is no issue of generating weights and everything. Very good. You just leave them there. Disadvantages: you completely avoid hierarchical dimensions. Do you want to provide more importance to one dimension vis-a-vis others? No answer in general. A single headline figure is often very strong. I mean, one of the reasons why GDP, HDI, despite being such problematic, they get the traction, mainly because single headline figures are really powerful politically. It is the truth. Yeah. In general, SDG, for example, as you were saying, 170 indicators. And who follows 170 indicators at the same time? They are there. Do they serve the purpose? Do you really track them every year? Leave the question of trade-off in general out, because if you have improvement in another indicator, the other indicator is not progressing, how do we account for that? In general, it doesn't do. Big question for poverty measurement: if you ask, who is a poor person? No answer, because there is no way of identifying somebody. You can say, okay, this person is deprived in water, this person is deprived in sanitation facilities, this child is malnourished, but who is poor? How many poor do you have in your country? You cannot answer that question because nothing involved as such. And even when there is a need for looking at deprivations together, because it doesn't aggregate, so there is no way of looking at multiple deprivations. You look at them separately, and that's all. You leave it there. Yeah. So these are basically pros and cons of the dashboard approach or the macro, this joint approach. Now let's move on to macro aggregation approaches. Now you will see they have been, I would say, pre-2010 or pre-2015. You will see a lot of papers on methodologies, multidimensional methodologies. There is a multidimensional index, but basically this is what they do. They do not develop from microdata. What they do, so as Stiglitz and Senfitosi in the same report, they suggested that single summary measure has really strong purpose, and that is the reason why people create. So there's an entire handbook of composite indices. It was published in either 2005 or 2008 from the European Commission. So there is a big handbook on how to construct composite indices. Good that they don't call it multidimensional indices. They are not. They're composite indices. Yeah. An application is the human, in Human Development Report. Human Development Index itself is a composite index, but it's a composite index of human development or well-being side. These were the two measures that were reported in the Human Development Report to capture the multidimensionality of poverty. So they created a composite index. So it has 3 or 4 dimensions. Yeah, I'll show you. capability poverty measure and human poverty index. That was the first attempt. They tried to replicate the success of HDI, but they were not as successful as the HDI. The capability poverty measure is the equally weighted average of three indicators. They are aggregated average. And the methodology was simple: H1 H plus H2 plus H3 over 3. Just a simple average. Yeah. And human poverty index, again, use three different indicators. I think use child mortality, lack of access to water or something like that. I don't remember the exact three, but they used a general mean approach. But look, they used something greater than 1. Any idea why? Atkinson used less than 1. But they are using greater than 1. Any idea why?
Poverty was. We wanted to check how much poverty is there.
Yeah, but why?
They are inequality level. Because alpha is greater than 1, that is the person is more inequality level.
Yeah, inequality level. Here, in poverty world, higher value of an indicator means worse. So, in that case, you put more weight, larger amount, larger value of poverty, deprivation you get in that indicator.
Poorest of the poor.
No, you are discounting for larger deprivation in some indicators. What is the idea of Atkinson? If you have three well-being mentioned indicators, per capita GDP, education, and health, in all these indicators, more is better, right? Higher value means better, right? In per capita GDP index, higher value of GDP is higher well-being, higher value of life expectancy, better, and so on, right? When you're measuring progress, higher value is better. Then, if you have disparity across dimensions, you want to discount for that. That means high inequality across dimension is bad. So use alpha less than 1 to put more emphasis on the dimensions where you are lagging behind. In poverty world, your higher value, illiteracy rate, mortality rate, higher value is bad.
The part where alpha is equal to negative infinity in accordance with Law's law.
Yes. That means you are emphasized on the lowest value only. Right? In this world, you have deprivation. Higher deprivation is bad. Higher values is bad, right? Here, you would rather put more emphasis on the higher values. If you have alpha greater than 1, it put more emphasis on the higher value. So in case of poverty, you use alpha greater than 1. In case of well-being, where higher value is better, you use alpha less than 1. You emphasize more on the lower corpus. Here, you are discounting if somebody has higher deprivation in one indicator. So you use alpha greater than 1. Does it make sense?
So one more question.
Yeah.
So for the first point, you referred to a report by European Union. Was it GDP measuring progress beyond GDP? Or you referred
The composite index, the one I referred now or the last session?
No, sir, now.
This is a handbook of composite indices. The name. I didn't mention the progress mark. So handbook of composite indices, there's an entire book on how to construct a composite index, how to check their sensitivity analysis, robustness, and so on, but for composite indices. There's nothing to do, and these composite indices are based on macro data. And people always used to get confused. Those are probably they are different from micro aggregation approaches. These are mainly macro aggregation approaches. Yeah. Okay, so again, this is a geometry. It is not actually a geometric mean, it should be general mean. Sorry about that. I'll revise it. It is general mean of 3 dimensions, but the methodology they use alpha is equal to 3. Yeah, so these were the 2 poverty measures, an attempt to go beyond income poverty. Yeah, so these were the 2 poverty measures that UNDP came up in their Human Development Report in 1990s. And they were there until 2009. In 2010, they changed the methodology. Yeah. Okay. Advantages. biggest advantage is, of course, simple, easy to understand. It gives you a summary measure, which is very useful for ordering and ranking. If you think about, if you to a country or anybody, say to Indian government, you give data for 29 states for 7 years for all the 10 indicators separately, and you try to and tell them, okay, now you understand whether you have developed or not. It's very confusing. Imagine 29 states, 10 indicators, 7 years of time. Multiply them. Such a volume of data is impossible. So from that point of view, if you have a summary measure, that makes your life slightly easy. Yeah. Of course, given that they use macro data, they can combine different data sources. Possible. It can also combine information on disjoint population. Say if you have data on children, you get a summary measure. Data on women, a separate summary measure. Data on elderly is a separate summary measure. If you have two separate summary measures, you can just bring them. This one, it offers trade-off in that sense in terms of weights. So if you think some indicators are more important, you put more weight. Some indicators are less important, less weight. So they contribute less towards the progress and so on. So if you want that hierarchy, it is possible. Of course, when there are too many indicators, you can try to sort of combining them. Definitely is better. Now, main disadvantage for poverty estimation. Again, no answer to who is poor. Even if we look at the capability poverty measure, it was an index, a number. Human poverty index, a number, right? If you ask a question, okay, who are my poor people? Where do I target? It cannot answer. Because what you are just doing, deprivation in water, deprivation in health, deprivation in education, you are summing them up, getting a number as a 0.7. What does it mean? What is the policy evaluation? I understand it is a sum total of 3 different numbers. How many poor people are there? There is no answer. Number one. Number two, another biggest problem, it does not even look at the joint distribution. Remember the example? There are two matrices. We had similar deprivation level in each indicator, but in one country, it's only one person who has been left behind compared to others. Those kind of situations cannot be captured. So if you, in your own time, if you try to do the average of these two matrices and they get a measure, you will see me getting same value. There is no way of differentiating these two vectors. So completely, joint distribution is completely ignored. And sometimes it may contain valuable information on component indicators. You will see when we will talk about discounting approach, you will see we will be able to open up after we aggregate. We will be able to open up to understand its distribution, understand which indicators are contributing, and so on. Such things are not possible with composite indices. Yeah. Okay. Let's just recall the achievement matrix, so that we will slowly now move on to micro database methodologies. Yeah. So I hope you remember that this is our achievement matrix. Rows denote anyone? Individual, and then columns, dimensions or indicators. Thank you so much. So this is how the data look like. We have, if it is possible to have the data set, sometimes population are disjoint. We don't have to force ourselves to create one. But if it is possible for us to create such achievement matrix so that we observe the performance of households in different dimensions, we get this achievement matrix. And then, of course, you know already the difference between marginal and joint distribution. Do you all remember? Yes, or do I need to say what is the difference between marginal and joint? Yeah, remember. Great. So then the two approaches, one is micro non-aggregation approach, which has its value. I will show you some examples where it is used. And then we have micro aggregation approach. Here, we have two types of aggregation. One is called column first aggregation. Another one is row first aggregation. What does row denote? Each row. And the columns? So column first approach means you first collapse the information for each dimension. Yeah. Then you aggregate across those aggregate values. Okay. So suppose you have this matrix. You start with x11, you go to x1d, you go to xn1 and xnd. Right? This is our matrix. So for column first aggregation, first you aggregate using the columns. So you aggregate this one, get say something called h1. You aggregate this one, you get h d to h1, h2, and so on. And then in the next stage, you aggregate them to get an index. This is called column first aggregation. So you first collapse data across columns, and then you aggregate them to come up with one number. This is called column first aggregation. Sounds good? Then the alternative is row first aggregation. You first aggregate row, you get something called, say, like y1. You aggregate this one, you get the yn. Of course, then in the middle you have y1, y2, y3, and so on. So you get one aggregate for each person first. And then in the second stage, you aggregate them to come up with an index. So these are the two basic ones that are used in the literature. A column first aggregation and a row first aggregation. Is it clear? Non-aggregation. Yes.
The column first means we are aggregating over the for a particular dimension, we are aggregating over all the elements. And for
Yeah.
And after that, we are also for like.
So you are, first of all, you are aggregating them to get a dimensional aggregate. And then you are again aggregating the dimensional aggregate to get one of the poverty index.
This is for column.
Column first. And for row first, you are aggregating for each person to get an aggregate index. And then you are collapsing this distribution, aggregating them, these individual figures, come up with an index.
So can you use for this aggregation, like, are we using any ways?
Wait, coming. All coming in due process. No need to rush. We have today and we have the entire tomorrow. We'll show you all these things. Not to worry. But first, understand these two different aggregation steps. Is it clear? Yeah. One is column first, one is row first. Yeah? Aggregation. Okay. So, these are the marginal distributions, right? Okay. So the question for you. Does or is, suppose a poverty measurement methodology uses column first aggregation. Say, methodology poverty index A uses column first aggregation. Is it sensitive to joint distribution?
No. Because we are using the marginal distribution.
So you are already aggregating the marginal distribution first, then you are aggregating across those aggregates. The column first aggregations are not sensitive to joint distributions. Make sense?
Yes.
So if you see a paper where you see people have already aggregated and they are saying we are collapsing, you know they are not sensitive to joint distribution. Joint distribution, sensitivity to joint distribution is at the heart of multidimensional measurement. If you are not doing it, it is equivalent to the macro aggregation approach, composite index approach. Okay? Good. Any questions here? No? All okay? So let us first look at the micro non-aggregation approach. So this is typically what is done with Venn diagram. So if you have, so here is a very simple example. You have this rectangle as the entire population. Within that population, this one reflects deprivation in one dimension, this one reflects deprivation in another dimension, and this is the overlap. So it some sort of gives you some idea about you can also choose the size of the circles to show the level of deprivation. So it gives you some picture about these are the deprivations in different dimensions, and this is how they overlap. Good graphical tools. Yeah. Then you have dimension 1, dimension 2, and then you have, this is called contingency table. Yeah. If you have binary indicators and you want to understand the association between them, please do not compute correlation coefficient. It does not mean anything. Please use just the contingency table. It gives you a much better idea about the overlap of different binary indicators. Okay. Does it capture joint distribution of deprivations? Venn diagram. Does it reflect, does it capture joint distribution of deprivations?
Yes. Yes. Yes.
Yes, right? Because you can see the overlap. Right? So it captures joint distribution. Yeah? Good. So this is an application. So various studies have used Venn diagram to come up or to reflect this joint distribution of deprivation. This one is from European Union. Yeah, a number of people at the risk of poverty or social exclusion. So you have, these are the people, say in Europe, 71.9 million at risk of poverty, 29.3 million severely materially and socially deprived, and 26.6 million living in households with very low work intensity. So they have identified these three indicators. They have identified, how many different people are there, but then they are trying to understand how much overlap we have. So this is one dimension. This is the other dimension. So you can see how many people actually, of all these people, 5.5 million, they're actually facing all three. Yeah. Then you have 8.9 million facing two, but not the third one. Similarly, 11.2 million people facing these two, and so on. So clearly, a very good graphical way of showing overlapping deprivations, using graphical tools. So if you have only 2 or 2, 3 dimensions, it's very good. Have you ever seen 4-dimensional Venn diagram, 5-dimensional Venn diagrams? Have you ever drawn in your life?
3 dimensions. 3 dimensions.
Three.
Table we have drawn,
Table, you have drawn 4 dimensions in table. Wow. So do I have the picture? I will see if I have the picture later. Sorry?
What was social deprivation or social exclusion?
They have an index of social exclusion. They have some indicators. Based on those indicators, they identify. I do not exactly remember exactly what they did, but Whelan and Brian Nolan, they have a lot of work on social exclusion. The social exclusion is slightly different in motivation than capability approach. They just look at the social exclusion approach where people are not able to participate in the society. Yeah. So they sort of come from a slightly different perspective, which is not basic needs, which is not exactly capability, from slightly different perspective. Yeah, but they use multidimensional measure for that as well. Yeah. It's mostly about related to not being able to participate in the society. Yes, so questions? What are these references?
What are these references for?
They use Venn diagram. No, they use their own Venn diagram. Yeah, so these are the studies. So when I wrote it has been used to study the overlapping deprivations, these are the papers at different point. They have used the Venn diagram technique because Venn diagram is a useful tool. If you have just 2 or 3 different dimensions, is to show the overlap, you do not have to present tables or whatever. People just find this graphical tool very useful. Yeah, so for a small number of indicators or dimensions, yes, you can use them. Of course, the strongest sort of positive is that it's a very good visual tools to show. If you have binary deprivations, it's very, we have binary indicators, it's very useful tool to show the overlap. Of course, it captures joint distribution, right? But otherwise, how to show overlap? And of course, it is intuitive, easy to understand, even for 4 dimensions. Hard to draw, but still, it works. Again, may not give you a clear message. It will show you how many people are overlapping and so on, but not necessarily it will tell you who are exactly 2. You know who are deprived in 3, who are deprived in 2 of those. Generally, no summary measures. So you get the picture, you get a good idea, but then where should the targeting go? How many people we should reduce? They don't have a complete summary measure. So if you imagine you are getting this picture for 29 states in India or 30 European countries, you have all the pictures for you. But then how to rank them? Who has more? Who has less? You have to look at the number. You have to write down, and this is what they do not do. Every dimension is converted to binary here. So anything beyond binary, there is no possibility. And difficult to read for 4 or 5 or more dimensions. Okay, here's an example. We actually drew it in the book, and I created it. Okay, it took a lot of time making sure that you have every single overlap and so on. Very difficult. If they're just very difficult to draw, imagine how difficult it would be to look at all the numbers and everything. Yeah. Okay. Next one, it's kind of non-aggregation approach, is the dominance approach. You all understand the meaning of dominance when we cover it? Yes? Right? So you do not need poverty line, you do not need poverty measure. If you have just stochastic dominance, home free. How do we do dominance when we have multiple dimensions? Show you some pictures. Yeah? If you can do that, very powerful. You do not have to select weights, you do not have to select poverty cutoff and all these things. You just show, you know what, poverty has gone down. So this is what you observed in 2 dimensions. You have seen this picture. Which one is dominating and which one is being dominated? Fy is dominating. So Fy has lower poverty. So how many of you would say that Fx has higher poverty? Please raise your hand. Higher poverty. Fx has higher poverty. Okay. How many of you do you say Fy has higher poverty? And the rest, you're neutral? Come on, this is high. Okay. Always try to think B1. If B1 is your poverty line, this is your headcount ratio. So for B1, which distribution has higher headcount ratio? So which one has more poverty? Not X, right? So Y has more poverty. So that means Fx is dominating Fy. So Fx has lower poverty, Fy has higher poverty. That's the idea in single dimensional world? Yes? This is a picture of multidimensional world, only 2 dimensions. If you have 2 dimensions, it becomes a plane. So you have 0 here. So this is the plane of 0, okay? And then if one is dominating the other, the curve has to be composable. Not curve, the plane. So you can imagine even in 2 dimensions, it becomes difficult to understand. You move to 3, 4, and 5 dimensions, life could be very difficult. And it requires a lot of statistical power. A massively large data set when number of dimensions is more than 2. Okay, just wanted to show you so that you know they exist. Okay. So advantage, if you have dominance, ideally in an ideal world, home free. You do not have to do anything else. You just say poverty has gone down, yeah, or gone up. Of course, this considers the joint distribution of deprivations because you are plotting these 3 dimensions in the plane. If you have dominance, you avoid the controversial decision Because whatever decision you take about weights and poverty cutoff, it will be controversial. Do not ask me about the question, sir, how can we avoid controversy? You cannot. If you're working not even in consumption expenditure, income poverty, you cannot avoid controversies. You have to make some parametric decisions. Okay, choice. Okay, disadvantage. The first and foremost, no summary measure, no complete order. Okay. It allows pairwise dominance, just like when we had the dominance test earlier. It allows pairwise dominance, but doesn't provide any cardinally meaningful difference. So you can tell whether poverty has gone out or gone down, gone up or gone down. You have no way of saying how much poverty has gone down or how much poverty has gone up. Yeah, just order it. That's it. 2+ dimensions. Very limited applicability for smaller data sets. You need exponentially larger number of data sets to get these confidence intervals and everything. You need a lot of statistical power to conduct dominance, even for 2 dimensions. More than 2 dimensions, horrible. And it requires some assumptions about relationship between dimensions, substitute versus complement, in order to be able to draw it. But I gave you some examples, some ideas why it's so difficult to determine whether dimensions are substitute and complement, because it's really difficult to empirically establish at what level dimensions will be substitute, at what level dimensions will be complement. And mathematically, if you just try to bring that assumptions at different levels, impossible. Mathematical tools do not exist. Yeah. So those are kind of the problems of the dominance approach. Now we are moving to micro aggregation approaches. Okay, is it clear so far? The different approaches, their pros and cons. Yeah. Now we are moving to micro aggregation approaches. First, we'll look at the column first aggregation approach. I have just presented there, right? So aggregate across these rows for each column to obtain these dimensional indices, as I have written here. H1, H2, up to HD. Yeah. And then aggregate across those indices. That's your column first approach. So you just aggregate first across this, then you obtain H1 to this should be HD actually, not H3. And then you aggregate them. Problem insensitive to joint distribution. So this is equivalent to using a composite index. And you understand, all of you, why it doesn't satisfy joint distribution? Yeah? Yes. Anyone wants me to explain? I'll be happy to. No? Okay, I have one no, but it's okay. I'm going with that. Row first aggregation, on the other hand, aggregate across columns for each person to get n different aggregates, y1 to yn. Yeah? We'll be showing there in the screen as well. So you have these ones, you aggregate like this to obtain T1, T2, Tn, I1, Y1, Y2. You aggregate them, and this is sensitive to joint distribution, but depending on how you are aggregating, it is possible to be insensitive with some parametric choice, but column first aggregation, there is no way of making it sensitive to joint distribution. Here, at least depending on how you aggregate, there is possibility to be sensitive to joint distribution. Okay, so if you are doing multidimensional analysis, it is better to choose that does row first aggregation rather than column first aggregation. Okay. So first, let's look at statistical approaches. There are various statistical approaches you may have heard about. In general, some of them may be used for identification, some of them are used for aggregation, sometimes both. And they are used during measurement design. Either they are claimed, but I generally do not support them, all of them. They definitely are good at exploring relationship that they claim, and then they're used for setting weights. That bits I have a strong proceedings. Okay, I do not buy the way they do. Now, what are they? These are their classification. Okay, so statistical methods can be descriptive and can be model-based methods where they assume a latent construct just outside. Now, the descriptives would be cluster analysis, principal component analysis. Some of you may have heard about it. Yeah. Multiple correspondence analysis. Yeah. And then model-based would be latent class analysis, factor analysis, structural equation models, and so on. So if you look at principal component analysis or this, but the main idea is to how much variance on the left-hand side can you explain? That's the main idea, even for principal component and many other. So you have your latent construct or left-hand side variable, and you are just trying to explain how much of this variance can be explained. So on the right-hand side, you have all these indicators, right? And these indicators, you have correlation between them. So what it tries to do, it tries to exploit that correlation structure and then try to find out the linear weight that explains most of the variance in the data. That's the basic idea of fine. It's a descriptive tool, statistical tool. Should we take the weights generated by them as normative weights? No, because they are only dependent on correlation. So here's an example. In a particular data set, access to water and access to sanitation, they are highly correlated. Most of the time, what this will do, this will say put 0 weight on one of them. You do not need. Would you dare to delete either the sanitation, the access to sanitation, or access to drinking water from your data, from your poverty measurement? Hard to justify, just based on. So you have to be very careful, just blindly using these statistical methods to generate weights or indices, and then try to do poverty measurement analysis. Also, sometimes they provide scores, principal analysis score. You will see if you have you used any of you demographic health survey data. Any of you? Okay. Have you seen they have wealth index? Wealth index is generated using principal component analysis. And the best they can do is create quintiles or percentiles. Because the scores themselves, you will get a score of 1,532,000. I have no clue what that means. It's a score. Okay. So what they do, they just create percentiles. Now, once a person proposed to me, okay, let's just consider the bottom 20% as score. Good. So that means you take 1 year, identify the bottom 20% as score in 2000. You go to 2005, you identify the bottom 20% as score. You go to 2010, identify the bottom 20% as score. So your poverty rate is 20%, 20%, 20% throughout. What's the point? Okay. So again, they have been heavily used. Probably they are useful to cross-check, cross-validate for robustness, but they should never be used to construct weights or construct poverty score and all those things. I would never suggest that. Yeah, and they're not intuitive at all. So this is how they work. So you start with the achievement matrix. N times D. I wrote small n times D. It should be capital H just from the book. It's slightly different notation. I have just copied from there. So you have the matrix you start with. Then you reduce the matrix of combined achievements. And definitely it's a dimension reduction techniques. So instead of 10 dimensions, it is possible they reduce it to 7 or 8 dimensions based on the correlation structure. So they will drop some of those things. As I told you, between your water and sanitation, sanitation, if they're high correlation, they will say drop one. So they will drop, you would not even know which one they dropped and why they dropped. Just looking at the data, they will say drop one. Yeah. And then, so they get a reduced matrix, right? And then stage 2, they have a vector of person-specific achievement values. Then you get collapse to n times 1. So every person has some number, some score, which can range from minus 1 million to plus 1 million and so on. Again, there is no intuitive interpretation. And then some of them will find out and aggregate. Very hard to interpret. Some of them will just leave it there. So if you look at the demographic health survey wealth index, they just leave it there. because average or whatever doesn't make any sense. That's basically the summary of all the statistical approaches. This is what we do. Okay. Have any of you used statistical approaches for your poverty exercise? No? Okay, good for you. Okay, so if you look at the advantages, of course, it considers the joint distribution, which is a really big advantage. It's looked at the microdata, it aggregates, it captures the correlation and so on. By the way, another thing, principal component analysis must not be used for binary or categorical variables. It's just incorrect. People do that, but please don't use that. It just doesn't work. Yeah. You may have to use, if you want, you can use the MCA, multiple correspondence analysis, but not PCA.
What's the wealth index, which was provided by DHS, it was constructed by using PCA?
It's wrong. Don't use it. If needed, just use the data, raw data, and construct your own index. You may have similar ranking, but not all the same. But use of PCA on binary variables is just wrong. Don't use this. Okay. When the variables are binary, sometimes you explore correlations as well. You just look for between two binary variables. It doesn't make any sense. It's wrong. So you rather use the contingency table and look at the overlap or non-overlap. That gives you a much better idea about the correlation between them. Yeah. Okay. Disadvantages, poverty identification and measurement, of course, they are not very transparent. It's like a black box. What is going on inside, you have no clue. You just don't know. It is not straightforward at all for communication. Yeah. Identification is mostly relative, top 20%, bottom 20%, bottom 25%, based on the score and the correlation that you get. Comparison across space and time becomes really difficult. So suppose you are constructing these using multiple correspondence analysis or PCA. Yeah. And suppose you have 120 datasets for different countries. So you are running the PCA for every country or MCA for every country different, right? You will get completely different set of weights, different set of vectors. How do you compare them? Or suppose you compare between 2000 and 2010. Suppose you have the data sets. As Pratap showed you, you append them. You run the principal component analysis, factor analysis for the entire data set so that you get one weight. Fine. Then in 2015, you will again append the three data set and run again, but then you will get a completely different set of indicators. So every time, as if you have to estimate the previous version. Otherwise, they are not comparable over time. Yeah. Then my colleagues recently, Ricardo and Gaston worked at Ricardo still works at OFE, Nogales. Gaston is my co-author, and he's my co-author as well, Indranil Datta. So they wrote a paper recently in Journal of Development Economics, and they sort of suggested caution when you are using. They call it an endogenous weight, data-driven weight, right? If you are generating those weights from the data, they are data-driven weight. So they are endogenous weights. You're asking data to generate the weight itself, not coming outside. And they show clearly that this data violates monotonicity and subgroup consistency, which is kind of an extension. So in our book chapter, we discussed them a little. They formally established it that clearly violate these two axioms. Now, if you violate monotonicity, imagine what you will get. Actually, situation of the poor has improved, and you see poverty has improved over time, societal poverty. Or violating subgroup consistency, that means you have improvement in poverty in different regions, but overall poverty actually has gone down. So you ought to be, so I paid, more research, further research. Honestly, I wanted to research at that point of time, but then there are other important things to do. If we do research, even some of you, if you are interested, take the challenge. If you find and try to look at other properties, you will see it's not only these two. If I am talking to you 10 years again in future, I probably will be able to say it violates even more properties. They will be even more dangerous. But so far, in 2021, they have actually shown, of course, when COVID came and it's going to slow down. But at least during that period, they showed these two properties are definitely violated by indigenous weight measures or statistical approaches. Yeah. So please be cautious whenever you are using or somebody suggests you using the statistical approaches. They have their use, no problem. It could be exploratory, but it should not be confirmatory. Do not try to generate weights and everything or create a poverty index based on these methods. Questions?
Any kind of indexes which you have been constructing by using PCA.
Yeah.
So it violates those kinds of non-fullness P and stuff. And all those PCA calculations for the derivation index, they are wrong.
Should be. It's not about wrong or right, but you should know that they violate this property. So in some cases they may be right, but in some cases they may be wrong too. I cannot rely on them. Imagine the situation. You are driving the car, right? Steering is going to the left. You are doing this, it is going to the left. Would you rather drive that car? You do not know which way it will go. So you need to have that confidence that if I press particular button in my flight or in my car, it should do exactly what I want. This is what the properties are for. They provide you guidance. If they're violating this property, so they will say half of the time tossing a coin. Principal component analysis, I see poverty has gone up. Tossing the coin. 50% you are right, 50% you are wrong. Would you rather use that measure? So you need to be cautious whenever you are using the statistical approaches. They may violate different properties and they are not explored yet. These are just two of the properties that have been explored. Rest, whatever they violate, have not been explored. For example, this is another example. So we have seen coefficient standard deviation, as I told you, as a measure of absolute inequality, right? When Pratap was showing as well, when you give the sum command, have you ever given the sum command instead ISUM?
Yes.
What outputs do you get?
Minimum value, maximum value, standard deviation, mean, and output.
You get standard deviation, right? No, the standard deviation you get by sum command is not a measure of inequality. You know why? When we, let me write. So the formula for standard deviation is going to be square root 1 over n, sum over say I equal to 1 to n, xi minus x bar whole square. Agree? This is standard deviation, right? The theta standard deviation, instead of n, divides by n minus 1. It's sample variance. So if you double the population, it violates population invariance. Theta standard deviation violates population invariance. So never ever take the stored value of theta to create the inequality measure, standard deviation. One of my World Bank colleagues did that when they were creating a software. And I could not match. And it turned out he just borrowed as a shortcut the standard deviation from theta, which is the sample variance. It took us 1 hour to find the problem, but we learned something. Okay, so if you have to take standard deviation, please compute it using your own formulation. So everything that you try to borrow from theta, just be sure to check that they have computed exactly what you want. Otherwise, you'll be in trouble. So that's why I do my own code all the time. I do not borrow codes from elsewhere.
But when we use command they provide the variance.
Sorry?
If we give the command comma detail, then they will provide the variance also in there.
Okay, you should go and check, open the ADO file. Do you know that all data commands has a corresponding ADO file, ADO? Please open the ADO file and check what exactly they are computing. Otherwise, if you do not want to work so hard, Just write a code for yourself so that the variance will be, or standard deviation will be computed based on how you want. Should not be that difficult. Okay? It's simply this formulation, right? Yeah. Do you have a question?
And was the software added?
Added, yeah. Why? You have used added?
I was just curious because when you mentioned that it copied the.
Yeah. It's added. So, and my colleague was writing the code. He's a really high level programmer. I mean, I'm no more at the way he codes. It's very good. And whatever, I do not believe software. I have to calculate everything in Excel or using small 4 or 5 numbers. You know, if they match, I believe. Otherwise, try to cross check everything. They're right. For example, this iniquidate0, the command I showed you, it has another version called iniquideco. Instead of 0, it writes 4. That command doesn't work with 0 value. Okay, so that's why Stephen Jenkins had to update to iniquidate0, which works. So you learn all these things. It's always better to take 4 or 5 values and cross check if you are getting the same value if you put in the software. If that matches after 1 or 2 things, then you know they're correct. Okay, I mean, most of the times, data journals, if they go through data journals, most of the time they're correct, 99% of time. But at it, they were building the software at that point of time from scratch. Beautiful software, yeah. But then I had to check everything, right? Because I was writing the book, and you will see the World Bank book that I suggested you. You will see the 3rd chapter has all the tables. If you just insert the data, all those tables are supposed to be created automatically in this added software. So we had to check all the formula, if all the numbers are correct and everything, and that's where we found the standard deviation formula. It would have been a serious mistake. Yeah.
I think I remember maybe. They said that you can use tetrachoric or polychoric PCA case.
Tetrachoric, polychoric. So idea of tetrachoric is that you have the binary variables and somehow you create with some parametric assumption, you create a distribution that is continuous. Right? Do you know the idea of tetrachoric, or are you asking me what it is?
I'm saying that can be used in case of binary variables.
No, I do not suggest use. I don't believe all these things because the main idea is that what they do, you have 0, 1, you have 0, 1. So using that structure and based on some parametric assumptions, that assumptions could be challenged. They create a continuous code that lie between 0 and 1. And then they apply Pearson's product moment correlation to come up with a number. Again, you know, I am a theoretician, I'm a methodological person, and I question every assumptions. Every assumptions I presented, they can be challenged. So I suggest not using. I know in sociometrics, people use quite a lot. I would rather rely on what I can see rather than not knowing what is happening inside. So I would still suggest, just if it is for binary variable, please look at the contingency table. So I do not rely on, I know they exist, they are statistical techniques, they may have their reasons, but they have their assumptions, they are questionable. So that's why generally I don't rely on polychoric, or contingency table just allows you to see the overlap by yourself and make a decision. Do I believe that's high enough or small enough? But I agree, there are in sociometrics they use quite a lot. Yeah.
One small query.
Yes.
Regarding the standard deviation, where by default.
Louder, please.
Regarding the standard deviation, by default take 1 upon n minus 1.
Yeah.
The assumption that we are getting the sample data. So to make it, unbiased in our estimations, one medicine is fair enough because we are getting the sample data in our application. But is it the case that why do we estimate the index with weight or without weight? If we are taking with weight, probably it is actually representing the population, hence it has to be 1 upon n. If it is without weight, then 1 upon n minus 1 is also justified.
No, not as a measure of inequality, because it violates population invariance. If you do 1 over n minus 1, wireless population invariance. Because if you replicate the population, then your inequality measure should not change. Right? So if suppose you have 10 people, you go to 20 people, and you replicate all the vectors, then you should get the same inequality measure, absolute or relative. Yeah? If you are going n minus 1, you are not exactly doubling the population. So you are going 1 over 9 to 1 over 19. Because in every time it is not 9 to 18, it is 9 to 19. You are literally not doubling. So as a result, you are not going to get the same standard deviation or same coefficient of variation. Yeah. So that's it. So even if you do it weights, I suggest just computing the variance or standard deviation, just creating the formulation. That is the x prime, xi minus x bar. Just take this data and just produce this number. It's fine. And then you can, if you have the once you have that number, you can just do it by region, whatever, and it will give you the inequality measure. Yeah.
Sir,
Yeah.
sir, could you please explain this that in PCA?
Yeah.
Situation PCA would be advisable, and if it is not, I mean, please explain this point which you already explained one. Comparison across space and time will be different.
Yeah.
Please.
Yeah. So you are asking why PC is justified.
Under what situation will it be justified?
Yeah. So constructing a poverty measure, PCA is never justified. So never use a PCA to create a poverty measure. Now suppose you have got 10, 12 different indicators. You are just curious to understand, they have different level of correlation. You are just curious to understand, if I even, what data, which one is more redundant, more correlated, and all these things. You can just cross check running for binary indicator, multiple corresponding analysis. For non-binary, you can check with PCA just to have some idea whether, with very high level of correlation, whether PCA is suggesting you any kind of data reduction, so that you at least know. Because sometimes we have to share the academic space or policy space with people from different fields, some of them do not understand. So you should be able to answer at least to them what is correlation leading to. That's it. I would not suggest using PCA to justify why you have not included one indicator. Now, suppose you have decided to drop one indicator anyway because you don't see any use of it. For example, if you have 100% electricity or 98% electricity incidence, sometimes people may say, its incidence is just so high, it has such a high level of electrification, probably it's not a relevant indicator for deprivation anyway for me. So people may choose to drop. You can just cross check with your PCA. PCA probably will also suggest dropping electricity. You can say, I have cross checked with PCA. From that point of view, robustness point of view, you can use PCA. Okay? Can I finish plus the query, or is it related to that query?
So, regarding PCA, I used to see many papers not from pure economics, from psychology or sociology, where they largely use non-comparative scales-based responses. So non-comparative, I mean, they're largely using the Likert scale, Staffel scale, or even itemized, semantic itemized scale.
Mm-hmm.
In those cases, variabilities are at least not in binary form, maybe sometimes more than 5, more than 7.
So if you do not have binary data, you can use PCA. This is what I said, right? For binary data, don't use PCA. Use multiple parameter analysis. For non-binary, you can use PCA.
But it's not in binary form. These are not in the scale form.
What in this form? It has 1 to 10 values or something like that.
Yes. 1 to 5.
If they are, if you can justify they are continuous enough, I think it should be good. Again, people doing PCA, they will give you a better idea. I'm not an expert on statistical methodologies. But if you do, I think it's still acceptable, PCA there. But again, not for constructing a poverty measure. If you want to explore the dimensions, correlations, even there you have a lot of ties. So I do not know how good PCA still is, because when you have ties, that means you have same values. It's categorical, right? I think still multiple correspondent analysis is a better choice than PCA. So PCA probably does really well when the variable is continuous, you have income and other things. Yeah, right. Second question was about this one. Yeah, so the idea is that when you say construct a poverty measure using PCA, you are taking the data, say data for India, you are running the PCA, you are getting some sort of weights to construct poverty measure, right? Now you take the data for Nepal, you run the PCA, would you get the same weights? Different. Now suppose you have computed India's data for 2010. Now you are computing India's data for 2015 to compare. Fine, you run separately 2015, but different weights, so no comparable, not comparable. The following what Prakash taught you, you have to append 2010 and 2015. Right? So you run a joint PCA so that your weights are same. Now you again get another data after 5 years in 2020. Now whatever you run and got the weights in 2010-15, they will not be the same if you run in 2020. Yes, 2020 separately. So you have to again append the 3 data sets to get the joint PCA, but the PCA you are getting will be different from what you got in 2010 and 15. So every time you get a new data set, ideally it would be you have to again append, and every time you run and your poverty computation should change because 2015-10 data had different PCA than 2000. So it's not good for policy because every time you are shifting your position. So ideally, theoretically, that could be the problem. So it becomes difficult. So you saw Nepal and India comparability is not possible unless you merge the data and run again. But what does that mean? Similarly, every time you get a new data set, and if you run the PCA separately, you get a completely different set of weights. Are they comparable? People try to justify they're comparable, but how? Does it make sense? Yes, no. No.
I mean, yes.
My answer. So whatever I say, did it make sense? Sorry, you said no, so I thought again. It's okay. That's okay. Can we move on? Is it okay? Make sense? Yeah. Okay. Then I move on to another type of poverty measures that have been used recently. Have you heard about it? Fuzzy approach. Have you heard about it? Fuzzy sets approach? Yeah. Some of you. Okay. Some of you did. Some of you not. Okay. Fuzzy set approach developed completely independently following same to these approaches such as poverty gap, square poverty gap, and all this. And here's a funny story. So I was presenting these one of our papers from OFI in Oxford at some point 10 years ago. And this guy again was traveling from, I forgot which country he was traveling from, one of the African countries. He was working on African Development Bank. He was presenting a paper on using PCA. And so when we were presenting the axiomatic stuff and all this poverty gap, square poverty gap, he came to me and asked, use these things these days. People used to use them in 1980s. They're old. I said, what do you mean? I had no idea what he was talking, but he thought these things were obsolete. Principal component analysis is the future. We had to face this kind of thing. Anyway, fuzzy set is an example. The field was developed completely separately, as if independently of this other axiomatic literature. Yeah. So their idea, their starting point, they also started following same, but from a slightly different perspective. Okay, let me explain how they start. So their starting point is that we use poverty cutoff, poverty threshold, poverty line, and you all have questions. Why is $1? Why not $1.1? Why not 0.9? We all question, right? They also question. They said they call it a crisp set. Yeah, so the division between poor and non-poor using one poverty threshold, they call it a crisp set. That is the terminology they take. So they follow this quote from Sen that it is undoubtedly more important to be vaguely right than to be precisely wrong. So instead of choosing one wrong poverty cutoff, why don't we try to be vaguely right? That means instead of proposing $1, why don't we say that a poverty threshold can range from 0.75 to 1.25? So rather than being precisely wrong, let's be vaguely right. That is where this starts from. Philosophically, really, I love it. It's an amazing way. It is nothing different from the dominance analysis. That's my point. Yeah, when I talk to them. So they use this fuzzy set approach to explore how to be vaguely right. That is where they start from. And they bring this fuzzy approach from, this fuzzy mathematics is used for production of refrigerator engineering. So they borrow this idea from there. Yeah. Okay. So here is the idea. So instead of, they say that this is the traditional approach. You have a poverty cutoff. We have all seen, right? Z. Yeah. So you have the poverty cutoff. Here you have as poor, and here you have non-poor. So if you are below the poverty cutoff, you are poor. That means you get a value of 1. Just they do it other way around. 1, and here you are non-poor. They call it traditional approach. What they suggest instead that they assign kind of a membership function. The membership function is that is a monotonic function. I will show you some examples. That means instead of dividing poor and non-poor, you create a degree of poverty. Okay, so as your income increases, you become less and less and less poor. This is called fuzzy unbounded. Okay, I will show you some examples of membership function. Then they have the other idea of fuzzy bounded. They say you should have two bounds, lower bound and an upper bound. These people are certainly poor. These people are certainly non-poor. Suppose this is, $0.75. This is $1.25, and this is where $1 stands. Yeah. So instead of taking this one, they take an upper bound below which they are certainly poor. Above that bound, they are certainly non-poor, and the middle, they assign instead of going from 0 to 1, they assign a membership function. So your degree of poorness will go down, and by the time you reach it here, your degree of poorness is low, is gone. You're not poor anymore. That's the basic idea of fuzzy sets. Make sense? Okay. Let me see. I think I left it open, this chapter for you. So these are different fuzzy membership function. Yeah. So the way how, so here you have for the minimum value, this one is unbounded, I suppose. So for minimum is fine, and then in the middle, it is just going down linearly if you are between the maximum and minimum. If you want to have a bound, this is your lower bound, this is your upper bound. So you are certainly poor if you are lower than the bound. You are certainly non-poor if you are in the upper bound, okay, above the upper bound. And in the middle, this is how your membership to poverty goes down. Okay, and they have different, so people have explored and they have different kind of mathematical formulations that we just listed in the book in case you are interested to explore by yourself. But of course, whatever you will get, your final number will depend on the membership function itself. This one is key. And I showed you in the book, we list different types of membership function that people have proposed in the literature. Yeah. Now, Advantages, it offers summary measures, just like other measures. It works in multiple dimensions. I just showed you the concept in one dimension, but it is multidimensional. You can use. It captures joint distribution of deprivations. Yeah. And it can be compatible with, as Chakraborty showed in one of the paper in 2006, that it's compatible with different methodologies. Yep. But it has some problems as well. First of all, the justification of membership function is very complicated. Yes, people come with different membership functions. Some says linear, some says convex, some says, okay, it is S-curve. But again, it requires a lot of robustness checks. Mostly provided. They are not mostly provided, but they should do, but that could be done. That's not a problem. Some membership functions sometimes misuse ordinal data. We talked about ordinal data, right? And so when they just take the codings as the values 1, 2, 3, 4. You saw the problem with the ordinal, right? That is one problem. Sometimes fuzzy set results conflict with dominance results. I will show you a couple of examples. And then, of course, I just make a joke of it, this one, but it's a serious one. What about the fuzziness of the fuzzy bound? They just said that was their main goal, right? To be vaguely correct rather than precisely wrong. And that's why they said that upper bound and lower bound, right? So I asked them, what about the fuzziness of your fuzzy bounds? Didn't they be changing as well? What about the robustness with respect to them? In general, no answer. Yeah. Okay. So unbounded membership function. If this is your unbounded measure, that means you define this degree of property membership. Just use 1 minus the HDI. Fine. Right? 1 minus the poverty measure, 1 minus the well-being measure. What is the difference? Why you need a poverty measure? Because this is what you are doing, right? You are assigning a value based on degree of poverty. So look at well-being, take 1 minus that, then that should be it. I don't see the novelty here for assigning that. Second, if you have, suppose this certainly 4, if you have any improvement, because they are assigned a value of 1, right? If you have any increase, will that affect the overall property? No, no change. So, in a sense, it is violation of strong monotonicity. Again, you see clearly why it violates. Similarly, suppose you have a progressive transfer between here and here. Okay? What will happen? You take some money from this richer poor and give it to a poorer poor. This poorer poor's income does not reflect any increase, right? Does it? No. Because note is all 1, right? On the other hand, here you have a reduction, right? So these guys' membership increases. So overall property increases because of a progressive transfer. So you see why it is so important to understand the properties and know how your property measures should behave to different transformations. They clearly violate the basic properties, just like the statistical measures. Again, ought to be careful. Is it clear? Does it make sense? Yeah? Yes or no? Yeah.
Money from the poorer section, medium poorer section to the less poorer section. You can, if we have the transport policy to inject it, we can do it from non-poor to the other poorer section.
Say it again, please. Maybe I'm very slow in the evening.
So actually, I'm asking me in the last case, we are going to check whether the transfer policy is working there or not. And in that case, any transformation from the membership is creating poverty more. But my question is that in this section, why should we make any transformation from the membership to the certain score?
It is not why. If that situation happens, accidents can happen, right? If that accident happens, what would you expect? Poverty to rise or poverty to fall?
It will be poverty will rise, but
No. What do you expect? Forget about
expectation is always to reduce the poverty.
right? Because you are giving it from richer to poorer. You do not even have to think like that. Something happens like here, suppose. you have somehow, because of a bad policy, some money goes from a poorer person to a richer person. What do you expect? Poverty to increase or decrease? Increase. But for this one, poverty will go down. Because no change for this one. Here, you actually have the other way around, right? So, anyways, either way, either side, it is possible to show that the transfer will be violated. So, what the main point I'm trying to say is that same with the statistical approach and here, they create it conceptually, but most often what people do in different streams, they do not bother about caring how poverty measures should behave because of different data transformation. Without that, if you do, whatever results you get, there is a type of uncertainty with your results. Your results, I may not be able to trust your result, neither should a policymaker. That's what I'm trying to say. Is that okay? Any other questions? Yeah. Louder, please.
Okay, according to the certainly, the first one, even if the person is in the membership path.
First one, you mean the top one?
No, the second. Yeah, you can take any one.
Yeah.
So, if my income is keep on increasing, but still I am below the poverty line.
Okay.
So according to Fuzzy, that means yeah, we are improving in the poverty.
No. So if you are here, you are assigned a value of 1, right? Certainly 4. So if your income increases here, there is no change. You are still 1. Just like the head count ratio.
Membership.
You are talking about this period.
This one, yes.
Yes.
And my income is starting improving.
Yeah. It will go up, it will fall, right?
Poverty line is still that
poverty line, they have no. For this one, for them it doesn't exist. I left it so that you know that there should be, but they ignore this one. They say you have 2 poverty lines here and here. The red color one. This is a lower poverty line, below which you are certainly poor. This is the upper poverty line, above which you are certainly not poor. But between this period, between these 2 lines, your membership goes down slowly. Now, I showed the linear. It can be like this, and it can be like this. There are different functional forms that people have devised. Does it make sense?
Yes.
Yeah? Any other questions? Okay. So, this one, last one is the violation of transfer. Now, finally, we reach to the axiomatic approaches. Yeah? The axiomatic approaches, the main idea is that there are 2 different types of approaches. One, but in both cases, what people do, people take into account what properties are satisfied and what properties are not satisfied. So all those papers written here, starting from 1998, all of them, what they have tried to do, they have proposed their measure, but they have verified what properties are satisfied and what properties are not satisfied. Unlike the statistical approaches, fuzzy set approaches, and so on. They would start with the assumptions that suppose I want my poverty measure to satisfy transfer. I want my poverty measure to be decomposable. I want my poverty measure to satisfy rearrangement. So they clearly state how they want their poverty measure to behave. And then propose a particular poverty measure. I'm not saying they don't have their limitations. But the good thing is that you know what limitations they have, because it's clearly stated that these are the properties my measure satisfies, these are the properties my measure does not satisfy. We talked about basic the rearrangement, right? Correlation increasing, correlation decreasing, right? The NPI that you have heard about it so much, is not strongly sensitive to that. It weakly satisfies, but it does not strongly satisfy. But it is clearly stated in the paper that this measure only satisfies weak rearrangement. It does not satisfy strong rearrangement. Okay? Fine. If you don't like, don't use that measure. but it is clearly stated. That's very important in poverty measurement, in inequality measurement, in income standard, because we have looked at the properties, right? If a property is violated, the main problem is that I'm pressing my brake, but my car speed is increasing. Now that's not conducive for anyone. So understanding that property is very crucial. So these are the list of measures. Again, these are in the chapter 3 of the book. So this chapter, in case you are interested, again, they require probably an entire class to go through them. So this chapter, what we have done, we have tried to discuss the pros and cons bit by bit for every different types of measures. Yeah. So these are the axiomatic measures where I just mentioned them here, but the entire process on how they are constructed, what they are, this is starting with headcount ratio, right? Then you have all those measures that I have, Chakraborty, Mukherjee, and Granade, for example. You see, this is one, starting with this one. This is the first one. So they are all listed here, their methodology one by one. Again, I cannot go through all the methodology because it itself will take me another 2 to 3 hours. Yeah. So they are all listed there, these different methodologies, what they use. Okay, I have presented some of the methodologies in single dimensional context. Most of them are just extensions in the multidimensional context. The single dimensional poverty figures I have already given to you in slides, they are written. They are just extension in the multidimensional form. Yeah. So all of them are thoroughly discussed. In case you are interested, all of them are discussed over here. Yeah, these are Burgundy and Chakraborty index, BC1. Go back to the screen. This is the one, this Burgundy and Chakraborty index over there. Yeah, the one, the paper I was telling you to read. So, okay. So most of them extends either FGT or Watts or Chakraborty, the CHUC index that I showed you in the poverty lecture. So the poverty measures that are presented, most of them are extension of one of these two. So I'm not going through them one by one. It's very boring. Sounds good, but they are just extension of these numbers, these figures. Okay. So the main advantage, of course, if they satisfy joint distribution, it will be mentioned. It satisfies. If they don't satisfy, it will also be mentioned. So you know they are satisfying or not. Unlike statistical approaches and persistent approaches where you do not know how they are behaving. Yeah. They offer summary measures and of course provides clearer understanding how measures behave due to different transformation. This is one reason why I choose to work in this area rather than the other ones, because I was not quite convinced that what they're doing. Yeah, I'm not saying they're not important. Definitely they're important on their own grounds, but I just did not find them as convincing as the axiomatic approaches. Of course, some of them are claimed as disadvantages, but that could be their strengths. Number one, relies on normative judgment so that you can ask anytime, okay, Shuman, how do you choose a parameter? You have asked that question to me, and I don't have answer to it. That's why you need to do robustness test. Is it a bad thing? Good thing? I leave it to you. I like it because at least I know what I'm choosing. Yeah. Now, no single measure of them can satisfy all the desirable properties that we presented. Some will. So in order to gain some properties, you have to sacrifice some properties. In order to gain that dimensional breakdown, you have to sacrifice sensitivity, association sensitivity, strong association sensitivity. In order to gain some, you have to lose some. You cannot have everything. Yeah. At least you know what you are gaining and what you are losing. I call it fuzzy set approach. It is not fuzzy set approach. It should be axiomatic approach. I have to revise some of those slides and then send it to you. Okay. So overall evaluation, approaches that use macro data, they are dashboard approaches or composite indices. If you see them in your paper, now you know that they definitely don't, they are not sensitive to joint distribution. Okay, they don't capture joint distribution. Then approaches that use macro data, you have Venn diagrams, dominance approach, they don't aggregate. But then statistical approaches, they are more exploratory, the relationship between dimensions. Fuzzy sets approach and axiomatic approach, they typically aggregate and come up with an index, and they are sensitive to joint distribution. Yeah. So this is the summary of all of them. Able to capture joint distribution, require micro data set. Of course, the first two, they don't. For the second one, all of them, yes, they are sensitive to joint distribution. Rest of them. Identification of the core, the first one, definitely no. This one may, depending on how you are using the Venn diagram. Yes, for dominance approach and for these last two approaches, statistical approaches may or may not. Provide a single cardinal index. First one, no. Composite, yes. They are not so much. The last two, they are yes. So if you look at them all together, it looks like these last two, fuzzy set and axiomatic approaches, they satisfy these three criteria. The problem with the fuzzy set approach is that sometimes they can violate transfer or monotonicity, some basic properties. Just ought to be careful. Okay? Does it give you sort of good summary of what is out there, what sort of are used, and so on? Yeah?
Yes.
Hoping this is the last slide. No, I have a little bit of left. Let me just have some quick discussions. You all must be very tired, but just 5 minutes, then I will finish. Yeah?
Last side, if there was some typo error.
Okay, tell me which one.
For the micro data, I think approach is using micro data.
There you go. Another typo. Yeah, I will try to rectify, but if you still find the typo after it is posted by Pratap, just send me an email to me, either me or Pratap. Yeah. Any typo, if you see, just let me know. They should not be there, but I'm an individual. I can make mistakes too. Yeah. Okay. So these are some very basic practical issues, but sometimes they become very important. Selection of dimensions and indicators. Yeah. Role of weights. How we use. The question was already came, right? How we use weights. We'll talk about it more. Okay. I will just keep it very brief. And of course, the question of sensitivity to distributions across dimensions, across individuals. Yeah. So when you select your indicators or dimensions, the purpose becomes really important. This module is about energy poverty. So definitely we are not going to select indicators which has nothing to do with energy. Yeah. If you are selecting child poverty, you have to select indicators that are relevant to children. There is no point in selecting indicators that are not. So first one, another important thing is targeting versus assessment. Yeah. Why are they important? If you are targeting somebody, if you are targeting somebody or a group of people, and you define the indicators, you select certain indicators, you ought to be careful that people cannot pick and choose and change their status to gain benefits for those indicators. For example, if you have lack of sanitation as an indicator, say in BPL, you include an indicator as whether you have sanitation or not. Then people may choose to, avoid building a sanitation facility in order to remain, eligible for the benefit, increase their likelihood. Now, assessment, you can use survey. For targeting, you cannot use survey. You have to do door-to-door census. Otherwise, you cannot do targeting. We use BMI as one of the undernutrition indicator, right? Measuring BMI in rural areas, carrying the weighing machine, not feasible. Okay, you need to have a proper place so that you can place the machine, stand on up, take proper measurement. Doesn't work. So whether your exercise is targeting or assessment, you have to choose and decide on your indicators really carefully. Yeah. Again, as I said, particular subgroup could be children, could be women. Again, you have to decide accordingly. International comparison versus national requirement. And as I was telling you earlier, global NPI, you don't have to use global NPI for your national policy design, because global NPI was created for global comparison. Okay? So you need to create measures for your purpose. For example, there could be a need for creating measures for people living in tribal areas. They have a completely different type of life. You may have to develop country specific. Sometimes you have to do state specific, because Indian government has created their entire multidimensional poverty. They are available for each district, right? Because NFHS is available at the district level. NSS cannot be used, by the way. That's why we never used NSS for multidimensional poverty analysis. It does not go beyond states. So for multidimensional poverty, you have to go at if you want to go district level, DLHS or the NFHS, they are the options you have to go to. But then for each state, they have used the measure to rank all the districts and all the states. The question is, all these indicators, are they relevant for all states? Yeah. I mean, use of heating, for example, may be relevant in North India, may not be relevant in South India. Right? So when you are developing energy poverty actually, so it's a question for you whether you will be able to use same indicators for North India and South India. Yeah? Or has to be different, how different it has to be. Question is then, even if you do at the all India or South India, North India separately, how will the national government evaluate your progress or distribute funds? For that, you have to have a comparable measure. So there are trade-offs. Again, conceptual foundation. If something is based on human rights, for example, you have to choose your poverty cutoff based on union approach, because every right is important. For capability, typically people avoid union approach. Why? There is one ground for avoiding union approach. So we're talking about functionings, right? Being healthy, being educated, and so on. But at the same time, we use achieved functioning. We do not observe the capabilities here, right? Now, is the achieved functioning, is it a choice or is it deprivation? We do not observe it, right? So somebody has chosen to be under BMI of 18.5, somebody is truly deprived. So if we do union approach, that means looking at least one deprivation. If you are trying to identify, there will always be mismeasurement or mistargeting. Because you have 10 indicators, the person is not deprived in other 10 because the person is well-to-do, but chose to be really thin. So it is always better to go beyond union approach whenever you are using capability deprivation. So have at least 2 indicators or 3 indicators. So if you have just one indicator, you may be deprived, but you have chosen to be like that. But if that is confirmed, it is not confirmed by any other indicators, there is no need to identify. But then your deprivation in health, if it is confirmed by 2 other indicators, that means it's probably overlapping, probably it has some truth behind it, because you are deprived in other 2 as well. So that's why for multidimensional measures, typically union approach is avoided. Yeah, but it may have good justification for using union approach. World Bank, for example, used only 3 indicators, just like the EU 2023, they use intersection approach. You have to be deprived in all 3 to be identified as multidimensional report. So people may have their justification. So there is no rule set in stone how or what particular poverty measure has to be, poverty cutoff has to be defined. Now, there is this idea of redundancy, and that works for many of that has been discussed heavily for many of the composite indices. HDI, for example, have been heavily criticized for being a redundant index. There is a big literature around 1990s saying that, claiming that HDI is a redundant index. Why? The idea is that you use multiple dimensions because they capture different things. Now, if they are really highly associated, for example, if you have a country or region, however you call it, whatever is needed, suppose you have A, B, and C, different societies, and suppose you have just two dimensions, D1 and D. Yeah. So this one, suppose this person is richest in this dimension, this person is second richest, this person is third richest. Yeah. And suppose you have exactly the same. Does combining them add any value to you? Would you get any different ranking when you combine them? You get literally the same, right? The question is, isn't adding one dimension reductive because one dimension is literally giving you all the information. So when HDI was constructed, they use correlation, Pearson's correlation, but then there are other types of correlations such as we'll talk a bit more tomorrow, Kendall-Stau, Spearman, rank correlation, and so on. When they used it, it appeared to be quite high, the correlation between among HDI indicators. So people started saying, it's a redundant indicator, there's no point in going beyond GDP and so on. So there has been a lot of discussions around redundancy issues. Yeah. So whenever you are determining on indicators, it is generally suggested that indicators within dimensions should capture similar things. That's fine. This is how they are supposed to be, because indicators within dimensions, if they are capturing two different things, probably they should not be clubbed together. It is fine for dimensions to be less associated, because dimensions should be capturing different things. And that is the spirit of multidimensionality, right? If they are capturing exactly the similar type of thing, why you include them? So that's why the choice of dimensions, and that's why you need the correlation test and all these things. You need to report whether they are highly correlated or not. Yeah, you have to make some judgment about that. So yeah, okay, Kendall-Tau is actually mentioned here. So Kendall-Tau, when you have more than two categories, you can use Kendall-Tau, and it can be adjusted for ties. And when you have binary variables, it is suggested that you use contingency tables and so on. Yeah, you understand. Okay, I will present some discussions about weights. In general, weights reflect relative importance in composite indicator setting. Weights in general reflect the importance of one dimension or indicator vis-a-vis other. If you feel or if you have enough justification to say that one dimension is more important than the other, you use unequal weights. But you will see many composite indices, they use equal weights, right? 1/3, 1/3, 1/3. Tony Atkinson, late Sir Tony Atkinson, gave us some suggestions. Said, why don't we select dimension in such a way that are of equal importance? If I ask you, between education and health, which one is more important? How many of you think that health is more important than education? Okay, and how many of you think education is more important than health? One. Okay, then in HDI, health should get more weight. How many of you think education is more important or income is more important? How many you go for education versus income? There you go. And how many of you think income is more important than health? Some. There you go. At least some. So you see, there's a circular process. Okay. Anyways. So in terms of macro aggregation, of course, relative weights capture some kind of trade-off. For example, if you have increase in one dimension, how much of these can be compensated? Because they assume some compensation, right, across dimensions. For micro aggregation indicators, especially for binary indicators, weight typically reflects the relative impact of the presence of deprivation in the household's overall deprivation compared to others. Yeah, so the interpretation becomes slightly different. We'll talk about more tomorrow, hopefully. But any choice of weights carries some sort of arbitrariness. So you need to conduct robustness test. Very much like what we discussed when we created the poverty measure for ordinal variables. You had the weights, right? You had to conduct robustness test. Ideally, how we do that, so here's an example for you. It is a simplex. It is called a simplex, right? It's a simplex for 3 dimensions. So in 3 dimensions, a simplex of weights looks like an equilateral triangle. So on this corner, you are putting all weights to the first dimension. Here, you are putting all weights to the second dimension. Here, you are putting all weights to the third dimension. Any other weights is a point and a convex combination of these 3 vertices. This is how you summarize all possible weights. You take the weight here, it will be a convex combination of the 3 vertices. You can choose any weight here, it is a convex combination of 3 vertices. This one is 1/3 of the top, 1/3 of this, and 1/3 of this. You take the 1/3 of 3 vertices, you get this particular weight, 1/3, 1/3, 1/3. HGI weight. Yeah? The idea is that whenever you are doing robustness test, you take a particular set of weights around this equal weight, and then you test robustness for all these weights. It will be equivalent to a dominance analysis. Now, there are some tractable conditions. There are some papers that provide particular set and particular set of criteria how to do robustness test. If you need, I can share those papers with you later. Yeah, but this is the main idea how robustness with respect to weight are conducted. Okay. Now there's some relationship between association and redundancy. Look at this example. Suppose you have created a composite index using this 2 dimension. Does it matter what weight you choose? Would the ranks change? You can have W1 here and W2, so that W1 plus W2 is equal to 1. Would it matter what weight you choose? Would the ranks change? No. Depends on the weight. But would it? This one has more in these 2. This one has second highest in these 2. This one has third highest in these 2. Would it matter what weight you choose? Would the rank change? No, right? Because you have higher value in these 2 than these 2. So whether you do 1, 0, 0, 1, 0.5, 0.5, this will always remain first, this will always remain second, this will always remain third, right? It turns out your comparisons are perfectly robust. No matter what you do, your ranks are not going to change.
Sir, but if we use unequal weight, if we use unequal weight,
Yeah, use 0.6, 0.4, 0.6, 0.4. How will it change? You have, suppose I'm giving you a value. It is 0.8, 0.8, you have 0.4 and 0.4. Now use unequal weights or weight. This is person, this is country A, and this is country B. Can you find any weight where they sum to 1, where you could say B is better than A? Can you? No, right? So if you have perfect ordering, that means here you have perfectly positive association, right? It is the association as its highest. It's perfectly positively ordered, perfect positive complete correlation, Kendall stuff, anything is a perfect positive association. If you have that situation, your comparisons are always fully robust. Okay? If they are perfectly negatively associated, they are never robust. You will always find weights where comparisons will be reversed. If you put higher weight here or there, it will just change the rank. So it looks like association between dimensions and the robustness is the trade-off. They go in different direction. So if you have a higher association, as a policymaker, you should be happy because all your comparisons are robust most of the time. Yeah. But if you select dimensions, so you see scars of dimensionality. If you have chosen dimensions that have low association, of course your comparison is less likely that your comparisons will be robust. Okay. Now this is, you don't have to be surprised. This is a mathematical fact. Should you choose indicators based on high correlation just to be robust? Well, you are distorting policy. But again, you know now these facts, how they are going to work. It's, if they're not in your control, you cannot just select indicator so that now that you know, you can go, and if somebody doesn't know, you can choose the indicator and say, look, I have got robust comparisons, don't complain, huh? But then you have selected them based on high correlation so that they're robust, right? But if you select them truly, the dimensions in such a way that they're capturing different things, that they do not have that empirical association, of course, they'll be less likely to be robust. So your robust, poverty elasticity or whatever, they will give you unreliable results, but that is expected. Don't be surprised. But you know now that they can happen. Yeah, that's the important thing. Make sense? Okay. The final one is sensitivity across dimensions, and we have discussed this several times, that sometimes you have to design measures so that they penalize for unequal improvement across dimensions. Across people in the multidimensional context, we generally have two different forms of inequality. And you understand now, one is transfer, just come from the inequality or equality within dimensions. And then the other one comes in forms of association between dimensions. Yeah, we have already discussed about Yeah. So these are some of the different multidimensional measurements and practical issues. So this is what we have done throughout the day. We try to understand the conceptual issues, different types of measurement, what exists there. It is good to know, even if you never use them, it is good to know what is there and how people may come and challenge you. Yeah, that's important. So tomorrow we will be trying to move into this particular countermeasure based on which the NPI is created, and we will discuss the relevant matters around that. Any questions?